I hope you have been learning about battery, all aspects of battery, how to use cells to make a battery pack. And the next chapter in fact is going to get into details of how detailed thermal design, mechanical design, electrical design and BMS is done in detail, elaborately. What however I want to bring a very small chapter today which is often not understood well. When I buy a battery, I pay a certain amount. It may cost 50,000 rupees, 100,000 rupees, 200,000 rupees, depending on the size of the battery. And then I use it. And use it. After some time, the battery capacity starts going down. And after that, at a certain point, I sort of say it's giving me too little a capacity, therefore my range is going down, I am going to replace the battery. That happens when the number of cycles get over, number of charge discharge cycles, because I will be charging and discharging the battery while using it. A question that is often asked, what is the effective cost of the battery per kilowatt hour? Because I know from 1 kilowatt hour I go so many kilometers. So to compute what is the effective cost of the fuel, in this case battery, I have to figure out the effective cost of battery per kilowatt hour, the cost of electricity per kilowatt hour, and then find out in 1 kilowatt hour how many kilometers am I able to travel on the average, which we have done using the kind of driving that we do, drive cycles, it will depend on that. Then we can compute effective cost per kilometers. Now this is an important parameter. For example, in a car today, even a small size car, the effective cost of petrol comes around 10 rupees per kilowatt hour. It used to be 7-8 rupees, it's now become 10 rupees per kilowatt hour with the cost of petrol going up. What is the effective cost of using electric vehicle? I have to, as I pointed out, to include a cost of charging 1 kilowatt hour battery, which is a 1 kilowatt hour, 1 unit of electricity, which will be 5 rupees, 6 rupees, 7 rupees. Then this effective cost of the battery per kilowatt hour, and I also have to obtain then the number of kilometers that the vehicle can travel per kilowatt hour, which we have done, and I think chapter 3 we have done that. So let me do this. It is something which is a techno-economic thing and not often understood. As I pointed out, that conceptually battery is similar to a tank, but unlike petrol tank, battery is expensive. Not only it has high capital cost, on the other hand, in gasoline, petrol is expensive. When we purchase a ICE vehicle, a petrol vehicle, we purchase inexpensive petrol tank and keep using more and more expensive petrol at operational cost. For electric vehicle, it is just the opposite. We need to purchase expensive battery along with electric vehicle, which is upfront capital cost, and then we use low cost electricity, lower operational cost. So the objective here of this chapter is, can we convert high capital cost of battery into operational cost, effective cost per kilowatt hour. Yes, I have to take the capital cost into account, I have to take the life of the battery into account, I have to take interest cost, because I put upfront capital, there is a certain interest cost. Interest cost is low in the West, 2%, 3%, maybe 4%. Interest cost is high in India, 10%, 12%, 16%, and we must include this because effective cost quite a bit depends on the interest cost. How do we do this computation? So cost depends, of course, capital cost depends on capacity, on number of cells used and cost per cells, as well as all the mechanical, electrical, thermal design, pack design. And as I told you, cost of cells depend on the chemistry, and the chemistry in turn will give you a certain life cycles when used in standard condition. And of course, we have also discussed enough that we need to take into account the depth of discharge, rate of charge discharge, usage temperature and usageable life cycles. Battery pack cost not dependent on voltage, a very important thing. Very often we think, oh, by fixing voltage we are going to decrease cost. No, it depends on kilowatt hour, energy capacity. 1 kilowatt hour battery should cost the same whether it is a 12 volt, 24 volt or 48 volt or even 380 volt. There may be marginal difference because the current will be smaller, so you may be able to use thinner wires, etc., etc. Your BMS may be slightly designed differently, your pack may be designed slightly differently, but those are marginal. Cell cost is the dominant cost. As I told you, we need to take into account cell cost, BMS cost, packaging cost and cooling cost. Cooling is very important, particularly for large battery. Of course, one important thing is percentage of cost of BMS and packaging and all other thing, cooling costs will go down if you have a larger capacity battery, because that is pretty much same, similar cost. And if you have a small size battery, it gets heavily loaded. If it's a larger size battery, it gets loaded small. Well, cell costs are dependent directly on the capacity. So if you have higher capacity, that is the dominant cost that determines the cost of the battery. Of course, as I pointed out, cooling costs also needs to be taken into account. How do I convert the capital cost to operational cost? The standard technique is you use what is called depreciation and finance cost. Depreciation, what is depreciation? A battery lasts for finite amount of time. So you, instead of taking the cost up front, you sort of say if it lasts for 5 years, the cost is the capital cost divided by 1/5 for 5 years. If you want to take it monthly cost, you have to divide it by 60, and that's a monthly cost. That's a linear depreciation. There are other kinds of depreciation in economics, but we will use mostly linear depreciation. So that is how much is the effective cost per month or effective cost per year of the capital cost. And of course, all the time I am paying interest, so I have to take into account. This depreciation and interest cost computation is done usually in EMI. All of you are probably familiar with EMI. EMI needs to be paid for. If you buy a scooter on loan, you need to pay EMI in installment or this installment. So it's basically installment is based on depreciation and capital cost. Actually, it's a very simple computation which every engineer must know. It is there in Excel. You open Excel and you can easily do this. There is a formula called PMT. PMT. The formula is called in Excel, and there is a function, and the PMT function says, okay, what is the upfront capital cost, what is the interest rate, how many years is the life, or how many months is the life, and do you want to pay any equal installment, which you normally do, and from there it will calculate what is called depreciation and interest rate. So in this case, depreciation will depend on an accurate estimate of the life of the battery, and life cycles is given in terms of number of discharge cycle, and as we have often pointed out that depends on number of parameters. So we have to have a good estimate. It depends on rate of charging, it depends on the temperature, etc., etc. Then we have to take the finance cost into account. I have taken all the way to 10 to 16%, because very often you even land up paying 16% interest cost, and this is important. Given this data, life cycle, cycles used per day, interest rate and capital cost. Cycles used per day is important. Why? You have got life cycles. Cycles per day used per day. Are you using one cycle per day? Every day you are charging, discharging once. Are you charging, discharging two? If it is you are charging, discharging 2 times, then it will last for half the time. Then your depreciation and interest rate need to be taken for half the time. So that calculation is important. Cost and effective usage of the bus. We also have to take into account other thing. we do not charge discharge fully. There is a depth of discharge. You understand that we do not charge at the bottom, we do not charge something at the top. So, the effective energy that you charge discharge is only the total minus whatever the is left uncharged, or if left uncharged or left discharged. So, you have to take that into account. So, DOD plays an important role. And as we pointed out, their cell capacity will keep on going down. So, that is called state of health, we have described that. So, the battery will not be the same. You start with 1 kilowatt hour, after some time it will be only 0.9 kilowatt hour. So, you will take that into account also. In our computation, we will assume here that a battery reaches end of life at 80% or 70%. Normally, that is what you use. If I initially got 100 kilometers, now I am getting 80 kilometers, 70 kilometers, I will certainly replace the battery. I do not want to use it. So, anywhere end of life is taken either as 70, 75, 80, a good thing will be 80. So, to simplify assumption, we will assume 0 resale value of the battery. Now, there may be a resale value of the battery. We can take that into account as a later on. And average about 90% or 85 capacity usage used throughout life. So, you do not necessarily every time you charge and then start using, you do not empty the battery and then use it. The battery is coming towards the end, you will like to charge it. So, on the average we will assume that 85 to 90% are you going to choose. Sometime you may discharge it till 95%, sometime you will fill it up at 80%. So, that also we will take into account. So, from this we now calculated usable life cycle or usable cycles per day. There are two parameters, usable life cycles and usage cycles per day, given the number of years of life. So, battery life in years, number of years for depreciation is called battery years, and this is the usable life cycles that is given in the battery, saying that you can use it for 1500 cycles. Now, remember that this 1500 cycles you can use in a normal condition, and if you are not using normal, you will use less number of cycles, but we will compute using the usable cycles as given there. And then cycles per day multiplied by 365. So, that will multiply by, you divide by 365 because that will give you years. You can calculate it in terms of days, in which case you do not divide by 365. What about usable battery capacity per cycle? Well, the maximum battery capacity that you can use is the actual capacity you started with, 1 kilowatt hour, 4 kilowatt hour, whatever is the depth of discharge, because you are only going to use that 85%. So, 85% plus multiplied by 1 plus end of life by 2. Now, why I have done this? End of life may be 0.8. So, end of life is 0.8, so 1 plus 0.8 is 1.8, divided by 2 is 0.9, on the average you are using 0.9. Of course, in the beginning you may use all of it, towards the end you will use only 0.8 of it. So, this is a method by which you are able to compute the average. So, this is the usable battery capacity per cycle. So, 1 kilowatt hour battery with 0.85 depth of discharge and end of life, suppose you take as 70%, then the usable capacity per cycle is only 0.7225 kilowatt hour, not 1 kilowatt hour. Why? You remember that towards the end anyway you would have got only, this is the average, 0.7 kilowatt hour. In the beginning you would have got 1, and then you are using only 85%. So, that is what you are doing. Average is 0.7225, quite close to the lowest that you will use. That is the effective use. Of course, I have taken here is 85% depth of discharge. You may do 90% depth of discharge, in which case you will get it slightly higher. Okay, that is the average. So, you think that you have 1 kilowatt hour, but effectively you have only 0.7225 on the average. In the beginning you will have slightly higher, towards the end you will have slightly lower. So this is what your range should be actually computed based on this, not for a new battery, but very often your manufacturer will never tell you. Now effective battery costs per year given an interest rate and battery years I have calculated, is this formula. Effective battery cost per year is this PMT of IR, the interest rate, battery years, and in the initial capital costs. This is the effective battery cost. Now I can of course also compute it differently. What is this formula PMT? We will get into that, but let's therefore, given that we have calculated battery cost per year, effective battery cost per kilowatt hour, but our interest is per kilowatt hour. So this is the effective battery cost per year. I have got that, divided by how many kilowatt hour have I used per year. So I have used the usable capacity multiplied by 365 multiplied by number of cycles per day. If I use 1 cycle, I can use 1.5 cycle on the average a day. What does 1.5 cycle means? Alternate day I use 2 cycles, other alternate day I use single cycle. So the cycle per day, this is the battery cost per kilowatt hour. So if I calculate battery cost per year, I can calculate battery cost per kilowatt hour, and I have simply simplified here the battery cost per year multiplied by a usable capacity. I have put it here as this, and then it comes to battery years divided by U cap multiplied by U cycle. This is the effective battery cost per year. Okay. So I have just taken this expression, battery years and cycles per day, and converted it into battery years divided by U cap multiplied by U cycle. That is the effective battery cost per year. Now, as I pointed out, the effective battery cost is depreciation and interest rate. So PMT is a formula that I said you can use Excel. But what exactly it is? Actually, this is the formula for PMT. It is a capital cost divided by a summation over a series. Suppose it is 5 years, so summation over 5 terms, divided by this, which is 1 into 1 plus interest rate to the power of n. So fairly involved formula if you do it for 5 years. You can actually do 1. So this will have to be added, battery cost, and in the denominator you have 1 divided by 1 plus IR to the power of 1, then 2 to the power of 3, because interest rate will impact what the total. If there is no interest rate, it should have been simple. 1 to the power n will be 1 and this will be 1. So summation will be the number of years. So if for 5 years it would have been capital cost divided by 5, but because there is interest rate, you have to do this. You don't need to calculate yearly, you can calculate monthly costs. If you want to calculate the monthly cost, suppose you have 60 months, now you can even do 55 months, suppose 55 months. So n will become 1 to 55, 1 plus, you can put the interest rate per month, you have to take the interest rate per year divided by 12 and get the interest rate per month. I am going to give you a homework problem, you should use this, and the same thing you get if you use a PMT formula. So you can use either of them and you will get it. As discussed, this can be used by using the above expression or can be used by the spreadsheet using PMT. Useful when usage cost each day and month is to be obtained in case where upfront capital costs are involved. Now, we will be using this formula several times, not just here effective battery cost. Later on when we talk about solar energy and wind energy and renewables, we will again be using this. So, please understand that this is something extremely useful for an engineer, and most engineers do not know this. Okay. So, I hope you would have picked it up. So, what I have done, I have done the computation. So, I have done effective cost per kilowatt hour, this is the expression, and I have done, this is how the expression comes.